Station, this is Houston. Are you ready for the event? Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
Houston ACR, station has you loud and clear.
Please stand by for opening remarks.
Good morning, everyone. I'm Jules Webb, Director of Education for the WEX Foundation in San Antonio, Texas. Brace yourself as you're about to hear from astronauts orbiting Earth at over 17,000 miles per hour. Now, here's our first question.
Hello, my name is Emmett T. Decker, and I attend STEM at Lee Academy. How do you see the Artemis mission opening doors for young entrepreneurs who want to benefit humanity?
Well, NASA is working with commercial and international partners with all of our Artemis plans. We're going to bring them along for sure. Right now, commercial companies are actually helping us get science payloads ready to fly to the moon. And also, they're helping us with constructing Gateway, which is going to be in orbit around the moon. And they're going to work on our spacesuits and even the rovers on Mars.
Hi, my name is Emma Brogan, and I attend Brogan Family Academy in Boerne, Texas. My question is, knowing how well prepared you are, what is one thing that surprised you about living and working in space?
One thing that surprised me is how three-dimensional our work is. I mean, we stand up straight in front of you, but we work on the ceiling. There's stuff everywhere, and sometimes at the beginning it's a little bit difficult to orient yourself. So that's what struck me at first at the beginning. What also struck me is how much fun it is to work up here, because floating never gets old and the view never gets old. So every day you have a big kick out of being up here on the space station.
Hello, my name is Rohit Siddipatula, and I will be attending St. Mary's Hall in San Antonio, Texas. And my question to you all is, how will information from the Artemis missions be applied while exploring Mars?
That's a great question. The first part of the answer is that exploring the moon through the Artemis program is a worthwhile scientific goal in its own right. Kind of like being on the space station, we're doing lots of scientific research up here right now, but a lot of the things that we do are going to enable our mission, our sustainable mission to the moon. So we're learning about technologies that can help us live and work in space, just like with the Gateway, we're going to be developing technologies further that will help us as a stepping stone to Mars. And all of these places, we live in a closed environment, which means we've got to reuse and recycle our air and our water. We've got to capture and distribute solar energy. We've got to have spacesuits so that we can safely exit our habitats. So all of these things we're getting better at here on Space Station will continue to get better in a lunar planetary environment, and that will all benefit our mission eventually to Mars.
Hi, my name is Siddhi Routh, and I go to Ronald Reagan High School in Texas. My question is, with the goal of the Artemis mission being to explore the moon, Mars, and beyond, how big of a role do you think entrepreneurs and their businesses will play in interplanetary colonization, possible terraforming, and building habitable structures?
Well, I think they're going to play a big role. As you might know, NASA is currently working with commercial companies to help create a space economy in low Earth orbit and on the International Space Station. So NASA is going to take all the lessons we learned from that and apply them to Mars, to the moon and Mars, because we want to bring all these innovative thinkers in the business world along with us.
Hello, my name is Penny Pim, and I attend the Artemis Academy in Texas. My question is, after the big space race in the 1960s, the curiosity of the public to explore space went down. How do you think the Artemis mission will spark that curiosity again?
It's a great question. Yeah, it's once somebody has won the race, do you keep watching? Well, generally not when somebody has crossed the finish line. But the interesting thing is we transition from a race to something more permanent, which is based more on cooperation, international cooperation, something more scientific, targeting innovation. And that's what we're doing today, exploration and innovation. And I think it's not an as efficient fuel to start as space exploration, but once you get there, once you have the race to start it, then the fuel of science and cooperation is really, really good to sustain it on the long term. And I think we've also been a little bit victims of our own success, because now it seems like we've been on low Earth orbit for more than 20 years, which is an unbelievable achievement, and that's really hard to do, trust me. But people kind of take it for granted because we've made it so safe that now it seems like it's just routine. It's just like we have the Olympics right now. If you're watching figure skating and there was no chance that those guys and girls would never ever fall, then nobody would be watching, and that's the point we're at. But I think going further and deeper into space, giving ourselves even more challenges is going to bring back the thrill of space exploration, and I can't wait to watch it or be part of it.
Hi, my name is Annalise Coleman, and I attend Keystone School in Texas. My question is, based on your experience and knowledge in the creation and operation of the International Space Station, how do you think future scientists should go about developing a lunar habitat?
Well, in fact, engineers are developing ideas for lunar habitats and technologies to support that type of thing right now. And the ISS is a test bed for those kinds of things. My two crewmates recently were doing spacewalks, and they installed new solar arrays, which is solar array technology that will be used in the Gateway Space Station. We also have to rely on all of the systems here in the same way that people will have to rely on them on the Moon and on Mars. And so, again, we have to have systems that are really robust, so hard to break, and we have to have systems that are redundant, so that if one does break, we still have another one that's operational. And then lastly, they need to be simple enough and easy enough that we can fix them in place. So all of these things apply to the space station as well as to the Moon. And then finally, you know, there are humans living here, and there'll be humans living in a sustainable habitat on or around the Moon. And so it's nice if it can be also a comfortable place to live. That's all the advice that I would give to folks as they're designing a habitat for future exploration.
Hi, my name is Advika Shankar, and I attend Communication Arts High School in Texas. My question is there a way that we can use tissue chips to study whether we can inhibit the replication of cells in microgravity in order to possibly cure cancer patients?
Well, tissue chips, as you might know, they're about the size of a credit card or a USB drive, so pretty small. And they allow us up here to model the structure, the mechanical forces, and the physiological factors of actual human cells, which is pretty incredible. Now, researchers, what they want to do is look at the effects of microgravity on human health and disease, and then translate that understanding back to help improve human health on Earth.
Hi, my name is Snigdha Tatampudi, and I go to Basis Shabano in Texas. My question is, changes on Earth, such as climate, sea level, and the axis shifting, has many people worried. What interesting changes, such as behavioral or visual looks, can you see from the station?
You can see a lot from up here. The space station is such a unique vantage point in our orbit, gives us access to, you know, almost all parts of the globe except the really high latitudes. We have a lot of instruments on the space station measuring all kinds of data, you know, in all kinds of frequency ranges and things like this. And it's important to remember that all the variables for climate are measured from space. I mean, this is from space that you can conclude, you know, that the global temperature is rising, that you can look at the sea level, that you can look you know, at the ice melting on the poles. This is not, you cannot deploy a fleet of sheep in the Pacific to measure sea temperature. You can do it, however, with a satellite in the right orbit. So that's one. And obviously, this is all this data that helps scientists on the ground conclude on climate change and its impacts. But also, I think what's important up here is we have like the human perspective, or just our vision, looking at what's happening, seeing the glaciers retreat, seeing all all the strong weather events like the thunderstorms and things like this. You can see this, and by putting this at your level rather than being distant phenomenon, very theoretical like they can seem to be on Earth, like we can see them and they happen kind of at our scale, the scale of what our senses can perceive. And doing this actually makes you think a lot about how fragile our planet is and the need to protect it. And I think that's the message that we want to pass along, to everyone when we come back on Earth.
Hi, my name is Lene Stewart, and I attend Great Hearts Northern Oaks in Texas. My question is, do you have farms in the space station where you grow your own food, or do you get all of your food from Earth?
Well, we get all of our food from Earth here on the space station from various cargo ships that come periodically to deliver food and other supplies. We do have the ability, small scale, to grow things on space station. And actually right now, Shane started just a couple weeks ago an experiment to grow New Mexico hatch green chili peppers in a facility right here on the space station. So the interesting thing about growing chili peppers is that they have a long germination time and a long grow period, longer than other experiments that we've done up here in space. But hopefully we'll get a chance to eat some of the chili peppers before we go home. But in general, on the scale of things that we're growing here, we're at the scale where we're still learning what's the best way to water plants in space, what's the best way to arrange them, what kind of habitat do they need, and controlling all of that on a smaller scale so that when we get farther from Earth, we can do it on a larger scale and do it simply and effectively.
Hi, my name is Adishri Jain, and I attend the STEM Academy High School in Texas. My question is, what instruments do you use the most on the space station, and how do you know where to position these instruments on the space station?
We use a lot of instruments when we're doing the experiments that we perform daily or the maintenance that we're performing. So I would say the things we use the most are tools. We use ratchets and torque wrenches and sockets and hex wrenches and all those kind of things. And they're kept in a very specific place for obvious reasons, so we don't lose them for one, and things can float all over the place. But we have a drawer system, and it's kind of like if you've seen a big toolbox that some people have in their garage or the aircraft mechanics have in their hangar. It's kind of like that, where there's a drawer for every specific tool and even foam cutouts for those. So our drawers up here are similar to that. We also use lots of cameras and lots of multimeters and other things depending on the experiment that we're using. But we have instruments all over the place. And on a different instrument note, we also have some musical instruments up here. Thomas actually has a saxophone up here that he likes to play every now and then for us.
Hi, my name is Linda Eva Gonzalez, and I attend Zachary Magnet School. My question is, after being in space for so long, how long does it take for you to regain your muscle strength?
Yeah, great question. It takes some time because no matter how active we're trying to be up here, no matter how much we work out, you're still going to lose, some of your muscle strength, some of your bone mass. And I would say, generally speaking, to get back to 100%, you need pretty much the same time you've been in space, so 6 months for a 6 months mission. However, it's not linear. You're going to regain most of your muscle strength pretty fast, and it's also not only muscle strength but balance, coordination, things like this. I think after 3 days you're back at like 50%. At least after 3 months you're at 95%. But you really need 6 months, I guess, to get back to 100% in everything.
Hello, my name is Sydney Holtorf, and I attend the data program at Ed White in Texas. And my question is, are any of you hoping to go on the first manned mission to Mars?
Well, I think any of us would probably say yes to a ride to Mars. But we also have a bumper crop of young astronauts that are coming up quickly after us. So we'll see. It's a little bit hard to say. But I'll tell you one thing for sure. If I'm not riding the rocket, I'll be there cheering them on the entire way.
Hi, my name is Elise Garza, and I attend Lamar Middle School in Texas. My question is, did you ever receive a piece of advice when you were younger that you would be willing to pass on to young people like me today?
Yeah, thanks for the question. I've been given a lot of advice over the years, but one that always sticks with me is to challenge myself and never stop learning.
Well, Hi, I'm Evan Rodriguez from John Jay High School in Texas. I was wondering, what jobs are there where I can help space missions from Earth?
There's tons of jobs, and that's a good thing. I mean, I think space touches everyone and everything, every walk of life, every sector of activity is represented. Obviously, there's a lot of like technical jobs or scientific jobs, engineers, scientists, technicians, and things like this. But not only, we got medical doctors, and you got all the jobs that are needed to make the agencies and the companies run. There's marketing, there's communication, there's finance, there's everything really. So if you have a passion in space, I think pick the field that you like the most and try to be good at it, and then send your resume to NASA and let's see what happens.
Hi, my name is Reagan Breeding, and I'm from Great Hartshorse Heights in Texas. My question is, when will y'all allow kids to go to outer space?
Well, Reagan, before we can say yes, I think your parents probably have to say yes. But each one of us works for our nation's space agency as a professional astronaut. So in order to get a job, first of all, you have to be old enough to have a job, and then you have to have the years of education to be able to do that job. But recently, you've probably seen that some private citizens have gone into space for a few minutes to experience that. And so I think you'll see more and more of that as time goes on, and as that new space industry develops a solid safety record and continues to kind of push the boundary there, you'll see more and more people going. So similar to aviation, the early days of aviation, you saw individual explorers and experimental aircraft, and then later maybe you saw only wealthy people enjoying an aircraft ride. But nowadays, families, all kinds of people, sometimes you see school children going on a trip. So one day we might have school field trips to the moon. You never know.
My name is Lord. I go to Loma Alta Middle School in Texas. My question is, how do you adjust back to normal activities such as walking when you return from space?
Yeah, coming back to gravity is usually not what your body likes. Our bodies now are so used to microgravity. When we hit gravity back on Earth, it takes a few days for sure, like Thomas was talking about, to get our sense of balance back. We can walk, which is great. That's really due to the workout program we have on the space station. So when you get back to Earth, you can walk around. You just feel really dizzy. So that goes away. You know, everybody's a little bit different, but say 2 to 4 days, that's going to go away. And then we'll start working out again into the gym to get it kind of all of our other systems back in place and our strength.
Hi, my name is Dayla Pyatt, and I attend Connolly Middle School in San Antonio, Texas. My question is, with all your proper training in space, have you ever had something unexpected happen that you had to come up with a solution for?
Yeah, I'm not going to say it happens every day, but it happens more often than you would think. And really, we and the teams on the ground, obviously, are trying to plan for everything. And there's a lot of work that's put into, anticipating every single problem that could happen and find a solution preventively. But in spite of this, it's space. It doesn't always cooperate. And only recently, I was on an EVA with Shane, and his helmet lights went off, and we had to figure out something kind of on the fly with what we had. We had never been trained for this. Nobody had a clear idea, but you do what you have to do. So we ended up fixing it. It wasn't really pretty, but it did the job. So I think it's all about keeping a positive attitude, trying to find solutions, not focusing on a problem, but focusing on a solution. And I'd say it happens more often than you would think, but generally a solution is always found, and that's good news for us.
Hi, my name is Rowdy. I go to Medina Valley High School in Texas. My question is, what is your greatest fear when you're in space?
Well, before we come into space, of course, we get a lot of training. We got lots of different kinds of training, but specifically we get emergency training to deal with situations that might be considered scary. For example, what happens if there was a fire? So we get lots of training with how to respond to that. We also know that the space station is designed and operated to minimize the risk of fire. So I don't spend a lot of time worrying about that kind of thing. What I spend time worrying about is kind of the day-to-day. So we make decisions every day that have consequences how we approach our daily tasks. So I want to make sure that I don't break something. I don't break somebody's hardware. I don't ruin somebody's experiment, or I don't make a mistake that causes one of my crewmates to get hurt. So those are the kinds of things that I worry about when I worry. And what you have to do is just bring all of your focus, really try hard to pay attention all the time to what you're doing, follow the procedures that have been written for you to get the job done correctly. And then when people have advice or are giving you directions real time, you really need to listen and pay attention. So those are the kinds of things I worry about, but we have good strategies for working through it.
Hi, I'm Dr. Cliff Zentgraff, the Chief Learning Officer at SAMSAT, the San Antonio Museum of Science and Technology. On behalf of our San Antonio community, a big thank you to the astronauts aboard the International Space Station for answering our students' questions and for inspiring the young minds of tomorrow.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants. Station, we are now resuming operational audio communications.